the tone, please state your name followed by the pound sign.
Ravi, you can get started.
Your call is on hold. Please wait.
क्या करता है, क्या कर दी? अरे यार, हेलो,
Hi.
Ravi, are you on?
Yeah, I've joined, person.
Okay, we can hear you now. We can hear you now. Go ahead.
Okay. Hello all. Sorry for that, and thanks everyone for taking some time out and joining us on the. Okay, sorry again. So many of us would have involved in various ETL stages and implementations, and could relate to the point that whenever databases are involved, knowingly or unknowingly, the ETL implementations are a little different. Now, this is when compared to other types of data entities like flat files, applications, unstructured data, cloud and web-based interactions. This is primarily because databases offer a unique feature called structured query language, which is also called a SQL. SQL offers unique features. For example, only required filter data could be read with the help of the where class. Similarly, SQL joins and subqueries could help with associating datasets. Moreover, database functions could be used to get the data in the required format. Hence, SQL capabilities could be utilized towards bringing the required right data set in the right format towards efficient data loading. Therefore, we may infer that efficient usage of SQL in ETL implementations could not only potentially increase the performance and efficiency, but also could reduce the ETL server and network load. We have just seen that the SQL offers several features towards loading and unloading data. This opens up the options of SQL usage in ETL implementation for efficiency and performance. Now, having said that, one of the primary challenges towards the same is that it requires considerable SQL proficiency. Now, it might be easy to come up with simple SQLs involving few joins, where classes, and order by classes, but it requires profound SQL expertise to fully utilize its advantages towards an ETL implementation. Further, each database type brings its own customization to the SQL interface, making things more complex. Another factor influencing such SQL implementations is the constant ETL changes that keep coming in. Coming up with a suitable SQL for such ETL requires quite a challenge. But changing such existing SQL implementation would also, to accommodate the existing ETL changes, could be even more challenging. Further, it is possible that such changes are drastic and very frequent. Not in the least is the scenario of overloaded databases. SQL optimization might not work at all on overloaded databases. In such cases, a complete reversal of any SQL optimization implementation becomes necessary.
Your line has been muted.
So can we overcome these SQL optimization challenges? I introduce Informatica PowerCenter Pushdown optimization. Let's look at a brief overview of PowerCenter Pushdown optimization and its positive points towards SQL implementations. PowerCenter Pushdown optimization, also called as PDO, is a session configuration through which the applicable transformation logic would be pushed to a source or the target database. When configured, PowerCenter Integration Service translates the transformation logic into SQL queries. Once generated, the Integration Service fires the generated SQL queries to the corresponding database. The source or the target database executes the SQL queries to process the transformations. Now, the amount of transformation logic that could be pushed down to a database depends on the database type, transformation logic involved, mapping and session configurations. Any transformation logic that cannot be pushed down to a database is processed by the integration service. Now let's look at a simple shown mapping where the ETL process associated is something like this. It extracts data from the source based on the source qualifier transformation, and the fetched data is then passed down to the subsequent transformations, aggregate and the rank transformations, and the resultant data set is, after some minor modifications in an expression transformation, gets loaded into the target database. Now, this is how a usual PowerCenter session associated with the shown mapping processes the data. If the same PowerCenter session is configured for pushdown optimization, attempt would be to push the appropriate transformation logic to the source and target databases. For this particular example, the rank transformation cannot be pushed to the database. Hence, an appropriate PDO SQL is generated to process the transformations up to and including aggregated transformation. Once such PDO SQL is generated, it is fired to the source database, and the result set is further processed by the integration service applying the rank transformation. The final data operations along with the loading data is then taken up by an appropriate PDO sequence and then fired to the target database. Hence, essentially both aggregator and exception transformations are processed by the source and the target database respectively, and the rank transformation is processed by the integration service. Further, assuming that the aggregator transformation has reduced the volume of data involved, the network bandwidth used for transferring data has reduced as well. Now let's look at another example for more clarity. In this one, data flows from source table SRC to target table TGT as it is, with few alterations done in the expression transformation. Now it so happens that in this case, all the transformations could be pushed to the database for processing. So this is a scenario where entire ETL processing is taken up by the database when configured for pushdown optimization. The query generated would look something like this. There will be a from clause which includes the source table SRC. The insert into clause would contain the target table TGD along with the corresponding fields into which the data gets loaded. The stellar clause would include the data to be loaded along with the modifications that go into expression transformation. For example, in this case, if function of PowerCenter is emulated by the case statement and the cast is SQL function is used for the data type conversions. Now, as I already mentioned, this is a special scenario of pushdown optimization where entire ETL logic is processed by the database. Integration service does not do any ETL processing, it just generates the PDO SQL as shown and then it fires it to the respective database. Now, having looked at few PDO examples, following is related to the possible PDO types configurable on a PowerCenter session. There are three possible pushdown optimization configurations that can be done. Source side, which essentially pushes as much transformation logic as possible to the source database. Similarly, as much transformation logic is pushed to the target database, it is an option called target side, and the full pushdown optimization would attempt to push all transformation logic to the target database. If integration service cannot push all the transformations, it performs both source side and the target side pushdown optimization, processing any remaining transformations that cannot be pushed down. Consider a mapping scenario that has a database as a source that involves a non-database target like track files and other applications. Source-side pushdown optimization could be configured in such cases. When a session is configured for the source-side pushdown optimization, the integration service analyzes the mapping from source to the target until it reaches a downstream transformation that it cannot push down. Integration service generates and executes a select statement based on the transformation logic for each transformation. Then it reads the results of this SQL query and processes the remaining transformations. Similarly, if the database is the target instead of source, then target side pushdown optimization could be configured. When a session configured for target side pushdown optimization is run, the integration service analyzes the mapping from target to source, or until it reaches an upstream transformation that it cannot push to the target database. It generates an insert, delete, or update statement based on the transformation logic for each transformation that it can push to the target database. The integration service processes the transformation logic up to the point that it can. Then it executes the generated SQL on the target database. Full pushdown optimization could be configured for mappings that involve databases both as sources and as targets. Please note that the full pushdown does not necessarily mean that the entire mapping is processed in the database. When a session for full pushdown is run, the integration service analyzes the mapping from source to the target or until it reaches a downstream transformation that it cannot push to the target database. If the integration service cannot push all the transformation logic to the target database, it processes the intermediate transformation that it cannot push and then pushes the remaining to the target database. The integration service generates and executes insert, select, delete, or update statements for each database to which it pushes the transformation logic. Now let's look at aspects of scenarios that involve multiple database connections. A mapping could involve multiple database entities, let's say as source, lookup, target, and so on. If all involved transformations could be pushed to the database processing, there will be associated PDO SQL generated. Now the question is, where would this SQL be fired? There are multiple connections involved. It should be fired only with one of the connections. And let's discuss on the related aspects of it. As seen, multiple database connections could involve when there are transformations like joiner, union, lookup, and target, other than the source. Now this is because each multiple database entities involved will have its own database connections configured on the session. To push a transformation with multiple connections to a database, the connections must be pushdown compatible in the first place. Connections are pushdown compatible if they connect to the databases that are on the same database management system, one single server as an entity. And the integration service can identify the database table that the connections are configured to. So essentially, each connection object is pushdown compatible with itself. So if you configure a session to use the same connection object for all the multiple connections involved, then they are pushdown compatible to each other. But some relational connections are pushdown compatible if they have same database type, username, and few more identical properties. Now listed are few such consolidated identical connection properties which need to match for them to be pushdown compatible. For example, two Oracle connections to be pushdown compatible, they should have the same connect string, code page, connection environment SQL, and transaction environment SQL. We have just seen that the mappings could contain multiple database objects which are internally accessible to each other. Now, in such cases, PDO-generated SQL would include all database entities according to the ETL logic. But however, the SQL needs to get fired in only one of the databases, and that is termed as an active database. The remaining databases are called as or termed as idle databases. For example, a mapping contains two sources that are joined by a joiner transformation. If the session is configured for source side, the pushdown optimization pushes the joiner transformation logic to the source in the detail pipeline. Hence, the detail pipeline becomes the active database. The source in the master pipeline becomes idle because the master database does not process the transformation logic. Similarly, for a lookup transformation, source or target database will be active, the lookup database itself will be idle. For full PDO, target database will become active, but the source becomes idle. The union transformation would have the first group as the active database, and all the other groups become the idle databases. With that look back, let's go on to the phases involved in a Pushdown optimization. Pushdown optimization consists of two phases: the analytical phase and the application phase. Analytical phase of Pushdown optimization involves traverse through the entire mapping. The traversal starts at the source quantifier and touches each subsequent transformation in the pipeline. For each transformation, it will be determined upon as to whether the transformation could be pushed or not. This process occurs with the session that has been configured to the source side or the full PDO. For the target pushdown, a similar reverse traversal of mapping occurs, analyzing the pushdown opportunities. Now, transformation is visited only if all the preceding transformations are visited during a forward traversal, or all the subsequent transformations are visited in a reverse traversal. If a transformation is on a branch, it may be tentatively marked for pushdown and consolidated upon when the branch merge is pushed. In the application phase, the optimizer inspects the outcome of the analytical phase to see if there are any identified pushdown opportunities. If so, the relevant PDO SQL queries are retrieved and are subsequently fired to the source and the target databases accordingly. Hence, the actual application of the transformation logic is performed in the application phase. It is implemented only when the respective PowerCenter session is executed. Now let's go on to the support aspects of the PowerCenter Pushdown optimization. The term database currently has overgrown, including all sorts of non-traditional NoSQL databases. Hence, it is required at this point to enlist the supported databases for PowerCenter Pushdown optimization. The support for Pushdown optimization includes IBM DB2, Microsoft SQL Server, SAP HANA, Netezza, which is also known as PDA, Sybase ASE, Teradata, Oracle, Amazon Redshift, and Vertica. Pushdown optimization also supports various PowerCenter operators, variables, and functions. When Pushdown optimization is configured, the integration service converts the expression in the transformation by determining the equivalent operators, variables, and functions in the database. Now, if there is no equivalent operator, the integration service will process the transformation logic. So for example, let's consider an aggregate function standard deviation. Now, it can be pushed to Teradata and Microsoft SQL Server, for example, because those do have corresponding function for standard deviation. However, aggregate functions like first have no implementations in any of the databases, so it cannot be pushed to a database for processing, and hence integration service will process it. During Pushdown optimization, the integration service converts the expressions in the transformation by determining equivalent operators, variables, and functions of the database. It also supports mathematical operators, comparison operators, and also the functions like count, decode, is, seasonal, and so on. The list can be retrieved from our documentation. Now let's enlist the supported transformations that could be pushed to a database. Not all transformations could be pushed to the database for processing. Aggregator transformation could be pushed, expression, filter transformation, joiner, lookup, router, sequence generator, sorter, source qualifier, target, union, and object strategy. These are the transformations that one can push to the database with the PowerCenter Pushdown optimization. We have looked at various support aspects of Pushdown optimization. So let's look at the associated caveats when Pushdown optimization is used or configured. The integration service and databases can produce different results when processing the same transformation logic. The integration service sometimes converts data to a different format when it reads the data. The integration service or database can treat null values differently. For example, if a sorter transformation to an Oracle database is used, you can configure nulls to use lowest value in the PowerCenter session, but the Oracle treats null values as the highest. They can use a different sort order as well for non-null values. For example, transformations could be pushed down in a session to SQL Server, which is configured to use a sort order that is not case sensitive. The session properties could be configured to use binary sort order, which is case sensitive. Hence, the results could differ. This difference could occur even in an expression involved in expression transformation or any other place where comparisons are done. The integration service and the database can treat case sensitivity differently. Further, they can convert the same numerical value to a character value in different formats. The database can convert the values, numerical values, to a format like scientific format when it tries to convert it to a string. Similar problems or issues can occur when there are different partitions for the data types of PowerCenter and the database. Another set of differences that come into picture is during error handling. When the integration service pushes the transformation logic to the database, it cannot track errors that occur in the database. When the integration service runs a session configured for full pushdown optimization, and when an error occurs, the database handles that. When the database handles the error, the integration service do not write it to the reject file. The rejected rows are not essentially flagged in a reject file. If you configure a session for full pushdown optimization and the session fails, the integration service cannot perform incremental recovery. This is because the database processes the transformation. If the database server fails or the integration server fails during the data processing, the database server rolls the transaction back. If the failure occurs when the integration service is creating a temporary sequence or a view, then those will be tried to generate again. When the integration service pushes the transformation logic to the database, it cannot trace all the events that occur inside the database server. The statistics the integration service can trace depend on the type of the pushdown optimization. Essentially, the session log does not contain details for transformations processed by the database. The session log does not contain the thread busy percentage when the session is configured for full pushdown optimization. The session log contains the number of rows read from the optimized sources when the integration service uses source-side pushdown optimization. Having said all that, the next step would be the settings to configure the pushdown optimization on a PowerCenter session. How do we configure it? Pushdown optimization could be configured in the Properties tab of session, and it could be configured to source side PDO, or target side, or full pushdown. The session also can be configured to allow temporary views and sequences, and also to allow user incompatible connections. To push the transformation logic to a database, the integration service might create temporary sequences in the database. This is required when the mapping contains a sequence-generated transformation. After the database transaction completes, the integration service will drop this created sequence. So essentially, a sequence object gets created in the database. The PDO SQL that gets generated will be utilizing this sequence object. And after the processing, the sequence object created in the database will be dropped. Now shown are the sample sequence that is created in the database, and also a sample PDO SQL that utilizes the created sequence in processing the data. A similar thing happens with the views. So whenever there is a SQL override in the view, or whenever there is a lookup filter, or if the lookup is unconnected, views need to be created in the database. So an appropriate view gets created in the database if this option is selected, and the created view then will be used in the appropriately generated PDO SQL for the data processing. And once the data is processed, the view is dropped. Shown again are a few examples of the view that gets generated and the appropriate select or the PDO SQL that utilizes the same. Now, if the database usernames are different across the compatible connections, otherwise compatible connections, let's say all required properties are the same, connect string, code page, and so on. It's just that the username is different. In that case, by selecting this option, you can make a session ignore the user incompatibility, but the following points need to be taken care of. One needs to verify that the database user of the active database has read permission on all idle databases. You need to also enable this property on the session. And for each idle connection, you must also specify the database name in the connection property and the table owners for all the lookups and sources. So for such, when the integration service generates SQL to transformations to an active database, the generated SQL references at least one table in the idle database. to ensure that integration service can identify all the tables. Qualifying of the names of the tables is required in these two cases. One is when the user incompatible connections are involved, and when the source qualifier has source filter or the user defined join. To qualify name of the source table, it has to go in the owner name of the session property for the source qualifier transformation. Similarly, a lookup table will have lookup table name session property, which needs to be filled appropriately. And these are the shown is the syntax on how to specify or qualify the table name so that the user incompatible connection is taken care of. For example, for Oracle, you need to give something like table owner dot table name, and so on. Now, depending on the database workload, one might want to use source side, target side, or full pushdown at different times. For example, you might want to use the source side or target side during the day when the database is loaded. But during the night time, you might want to use full pushdown optimization to utilize the database processing. Now, if the data does not get processed because of the database overload, one might even want to completely disable the pushdown optimization through this parameter called pushdown config. It's a mapping parameter. It's a string with a precision of 20. The options it can take is none, source, target, or full. Any of these can go into it, along with the additional options of creating a sequence of views and allowing the user incompatibility across the connections. Whatever is configured on this parameter is what is taken the override. Whatever is configured on the session is overridden by this parameter. So let's have a look at the demo. Let's consider a scenario of performing some sort of online shopping analytics. Now what is shown is a related data structure. So involved are the sources that we are looking at. So the involved tables or the database entities are the customers table, So yeah, sorry for that. So let's consider a scenario of performing some sort of online shopping analytics. Shown is the related. Sorry for that. There seems to be some technical issue there. So essentially, what I was trying to show was this particular data structure that is involved for this online analytics that we are looking at. Essentially, this would contain a customers table, which will contain the details of all customers that will be placing the online orders. The structure would also involve a products table that involves all the products that are open for the online shopping. And the order tables would capture all the placed orders online, which will internally have its own set of order items captured in order items table. Now all the shipped or the delivered goods will go archived or going into the order items old table. Now the mapping logic that is involved, which essentially will push down into the database is something like this. The order items and the order items old tables are read from and merged using a linear transformation. Then a lookup is used to get respective validations and filtered upon to ensure that the last 2-3 years of data is captured, which is then joined upon with the products table to associate the product related information. And then subsequently with few iterations, it is aggregated upon to get the total sales value based on the product type and the manufacturer, which is subsequently sorted upon and loaded to the target. So the essential idea is to capture the top sales for a given manufacturer and the product type. Now this is what we have under consideration to run it as a mapping and to capture it as a vision optimization opportunity. Now let's look at the corresponding session created. Now this is a normal session without any vision optimization configured. So what we see in the properties is that when we do not use the push-down optimization, which is selected to none, let's have a look at the query that is generated for the same. So this option called push-down optimization on the session properties in the mapping tab, this would execute the phase in which the query is shown in the window. Now this clearly shows that since the session is not configured for push-down optimization, no query will be essentially generated towards the push-down optimization. Now for the same session, if we configure the full push-down optimization, let's look at the query generated. Now this is the place where we configure for the push-down optimization. Along with that, we also see options like allow temporary view, allow temporary sequence, and the user incompatible connections. Appropriately, these options can be selected based on the ETL logics involved. So the analytical phase of push-down optimization now gives us a query with which this particular ETL can be converted into a single PDO sequence. Now as we look at it, we see that there's an insert statement that will load the data into the target. We also see the from and the other inner and left outer joins to incorporate data merges from various sources like joiner and the lookup. We also see a wait clause to incorporate the filter conditions and the order by and the group by clauses correspondingly for the aggregator and the sorter transformation used in the mapping. So let's quickly run this session. So now we have seen that this session has taken approximately 13 to 14 seconds to finish. I don't have the run currently, but this usually takes more than 2 minutes to run it without the pushdown optimization configuration. So that gets us to the end of the demo. Thanks, everyone. Now,
thank you so much, Ravi. So we have a couple of questions that are coming through the chat channel. Excuse me. So if anyone has any further questions, we have I think 10 minutes for Q&A session, so you can start sending your questions through the chat functionality that is available on the WebEx. So there is one question, Ravi, from a person called Neeraj Gupta. So the question is, for the transformations that are not supported by PDO, what is the recommended approach to implement them? So should we implement them in SQ through an SQL? Will this impact data lineage?
Okay, yeah, thanks, Neil. So the idea is that today in any mapping, it's not necessary that the entire mapping has to go as a pushdown optimization. So even if some of the transformations go onto the database for processing, we have seen that there is considerable, not only that the efficiency increases, sometimes we also see that the network load is reduced because right data is read in the right format. So in that sense, even if a couple of transformations are not pushed to the database, it's still we are better off than the entire transformation logic processed by the PowerCenter session or the integration service. I hope that's the point. Neeraj?
Thanks, Ravi. Another question from Arun Shukla. Can pushdown optimization work in case of mapping, which includes IDQ maplets like matching, transformation, etc.?
Well, yeah. So I think the answer is quite straightforward here. That only whatever I've shown in the slide is currently supported for pushdown optimization. So yes, IDQ maplet or any such other custom transformation would not be possible for a pushdown to a database for processing.
Another question from Edgar Sanchez. By seeing your example, I noticed that PDO has a join which calculated fields which may cause performance issue. So how does Infa handle DB performance?
Okay, so when it comes to performance specific to joiner transformation, so when database processes it, it just has to join the various data sets involved. But when it comes to PowerCenter, it not only has to read the complete data from both the database or data sets, and after that it can join using the in-memory or the file caches involved. So there is no automatic way of finding out whether database is processing it or slow or fast. If at all database is unable to take up the join performed across the table, we need to the developers need to go ahead and configure the session accordingly to stop the push down to that particular database. There is no session inbuilt intelligence to find out whether database is able to take the load or not. That is currently not built in as of now.
Thank you. Another question from Abhishek. If there are some files and Oracle tables as sources, in that case, can we do push-down optimization? Files and Oracle tables as sources.
Sorry, can the question be repeated, please, if that is possible?
Yeah. So the question is, if we have a few files and Oracle tables as sources, can we use PDO in that case?
Okay, yeah. So the question is that there are two types of data sources involved. One is Oracle and one is flat file. Now, since flat file data has to be read completely by the integration service, the pushdown optimization could still be configured, but it is as good as not configuring a pushdown optimization because the flat file source cannot be pushed to a database.
I have one more question here, Ravi. Can Informatica partitioning option be used along with PDO? And what are all the types of partitioning that is supported with PDO?
Well, partitioning is something that I currently have not much idea upon. I need to follow up internally and get back on that particular point as to whether it is first of all supported, and if it is supported, what are the types that is supported. So if you can capture the contact details, then we can get that on that point.
Sure. I don't have any further questions on the chat. I think we'll just give it another minute and then I think that there are a few more questions that are coming up on the chat. Ravi, just give me a quick minute. Abhishek, you can actually go ahead and ask your question over the phone itself.
Hi, actually, I got one. Hello.
Yeah, Abhishek.
Yeah, go ahead.
Yeah, actually, I just wanted to know that if suppose I have used some transformations, right, and few logics have been applied there, but somehow if suppose there is some logical mistake, some logical statements are there, so if I'm using PDO, so can we detect that kinds of logical error using PDO?
Well, PDO, what pushdown optimization does essentially, Abhishek, is that it tries to convert the complete mapping or partial mapping into the appropriate PDO sequence. So it won't, in that sense, it won't check what is the exact mapping logic. It just tries to convert the existing mapping logic into the SQL. So that way, there is no logical validations involved. So is that what you're trying to ask? Whether it tries to analyze the mapping and look for any logical inconsistencies?
Yes, I just wanted to know actually, while executing the code in converting into the SQL, the transformation logic, right? But I just pointing out like if there is some logical mistake, means suppose two fields are there included, but their data type is same. But I have just misplaced those fields in equality operations. So can we caught it using PDO?
Well, in that sense, PDO is not primarily for catching any logical or otherwise included mistakes in the mapping. It's only towards efficiency and utilizing database for processing. So in that sense, no, that would be a very bad idea to use to catch any logical or otherwise errors in the mapping. PDO is not designed for that.
Actually, why I'm asking because last time I have used PDO and I didn't handle that situation. I have misplaced the fields which data type was same, and it converted it into the SQL logic, but the data was returning bad. That is why I'm asking, can we caught it using my PDO?
Well, yes, we are lucky then, but it's a very rare scenario wherein the session log or anything else did not help you with those errors, but PDO helped you out. I think that you've been lucky in that, but otherwise, that's not a recommended way of troubleshooting any logical or otherwise errors that have gone into the mapping.
Okay.
Thank you, Ravi. I think we are just over the hour. So thank you so much for the presentation, and thanks everyone for attending. So a recording of this particular webinar will be available on our YouTube channel called InfaSupport. So that should be uploaded in the next 24 hours. And if you have any further questions, you can always go back and comment on that particular video, and we shall get back to them with our responses. Thanks everyone, and have a good day. Bye.
Bye.
Thank you, everyone.